So if you're studying for the atmosphere and weather test tomorrow, I'm going to try to help you focus on what part of the textbook you should be looking at. So it covers chapters 15, 16, and 17, but not all of the chapters. So way back over Thanksgiving, I guess, we looked at what gases make up the atmosphere, and that's important. Now, this first chapter we've been quizzed on a couple of times, so maybe 25% of the quiz will be on this chapter, and then the rest of it will be on later stuff. But so we've got, the atmosphere is made up mostly of nitrogen, about 20% oxygen, a little carbon dioxide. That's a greenhouse gas, giving us, because we're burning fossil fuels and all of that, we're contributing to climate change. Water vapor is important, but it's so variable, we don't put it in that chart, and it's what causes precipitation. The weight of the air pushing down is about 15 pounds per square inch, and it kind of matters how far above sea level you are, because if you're high above sea level, you have less air pushing down, so less air pressure. And we measure that with a barometer. We measure temperature with a thermometer. We measure wind with an anemometer. We measure, what else do we measure? I'm stuck right now, but okay. And remember, as you go up in altitude, not only does air pressure decrease, but air density decreases. It gets thinner. It's still the same ratio. It's still mostly nitrogen, 1/5 oxygen, but the number of molecules per breath or per cubic meter is much less as you go higher. Atmosphere is made up of layers. The layer we live in is the troposphere. In the troposphere, temperature goes down about 4 degrees for every 1,000 feet. And then you hit the stratosphere and the temperature starts to increase. It's that change in temperature that marks the divisions between the atmospheres. And above that, you have the mesosphere. That's where meteors burn up. And then the thermosphere, which includes the ionosphere and the exosphere. And that's up where satellites fly and where the northern lights are. And that gets us to this chapter. We didn't talk about air quality, so you can skip that section. And that gets us to chapter 16, weather factors. It's energy from the sun that drives all of weather. And there's kind of a balance between how much heat hits the earth and then escapes, and how much is trapped, and that's what keeps us at the temperature we are. Remember, if we had no atmosphere at all, it would be like the moon, where it would get really hot in the daytime and really cold at night. Winds blow from high pressure to low pressure. It's that difference in pressure that causes them to blow, and anemometers measure that. We're going to talk about local global winds and all of this stuff after Christmas break, so put that stuff off. Clouds form when warm, humid air rises and cools, and in the case of thunderstorms, we drew a thunderstorm. That makes it releases even more heat and makes them rise even more. Types of clouds: there's those cirrus clouds, the high wispy clouds. They're the leading edge of a cold front. Cumulus are the puffy clouds, and then stratus clouds cover the whole sky. If cumulus clouds have rain coming out of them, they're cumulonimbus, and if stratus clouds have rain coming out of them, they're called nimbostratus. Different kinds of precipitation, that's pretty straightforward. You're certainly familiar with snow. Maybe not this year. And then air masses. Air masses are labeled depending on their temperature and their moisture level. If they form over the ocean, they're maritime. If they form over the continents, and moist. If they form over the continents, they're dry. And if they form in the tropics, they're warm. And if they form over the poles, they're cold. And so all of these combinations are important. As air masses move, they don't mix with the air that's already there. Instead, they clash. And that creates fronts. These air masses are pushed by the prevailing westerlies. That's the winds that blow in this direction at our latitude. Down south, they blow easterly, or from the east rather, because of the trade winds. When they collide, there's a couple of different ways they collide. If the cold air is moving in where there was warm air, it makes the warm air rise and forms this cold front with a brief band of intense weather. If the warm air is moving in, it can't push that cold air out, so it slides up over. And we get a wide area of clouds, but it's gentle precipitation. So cold fronts and warm fronts, you need to know. Stationary fronts and occluded fronts, let's not worry about those. Cyclones and anticyclones, I use the term low and high, and I want you to stick with that. Forget about cyclones and anticyclones. And know the weather associated and how the wind blows around them. We looked at thunderstorms, and we drew one, and so you should know how a thunderstorm works. You should know about lightning, and that every 5 seconds the light of the lightning, when you see lightning, if you count how delayed the sound is, for every 5 seconds it's 1 mile. So you can figure out how far away that lightning strike is and determine whether it's safe or not. You should know what to do in a thunderstorm. Inside your house is best. If you're outside, getting in a car is good, not because of the rubber tires, but because the lightning will go around you and into the ground instead of going through you. If you're caught outside, you don't want to be under a lone tree out in the middle of the field. Stay away from tall pointed objects. Stay away from fence lines. Get as low as you can. Lightning likes to strike the tallest thing around. Then we looked at tornadoes yesterday and Tornado Alley and how that's where the cold air meets the warm, humid air and that severe cold front sets up. And as it moves across, it brings tornadoes with it. The tornadoes are the highest wind speeds on the planet. They're the most devastating, but they're generally small and short-lived. So hurricanes do more damage, but tornadoes do more damage in any particular spot. No tornado safety. First rule is to get underground. If you can't do that, put as many walls between you and the tornado as possible, because it's getting hit by flying debris that is the most likely way that a tornado hurts you. And then we looked at hurricanes, and hurricanes are a different deal because this is a storm that's been building for weeks. So you know it's coming, you have a chance to evacuate. If it's a Category 4 or a Category 5, there is no safe way of riding it out. You may be on your own for a couple of weeks. So you need to be prepared for that with food, water. Electricity is going to be out. If you live in town, the sewer is going to be out. So there's all kinds of problems that come with not having services for a couple of weeks. Your grocery stores and your gas stations are going to be closed. Your roads are going to be flooded or covered with trees. So you're not going to be able to escape probably once it sets in. So if you at all can, getting out of the way of a hurricane is the best way to handle it. And hurricanes are huge. They're hundreds of miles wide. So it's not like, it might miss our house and hit the neighbors. A tornado might do that, but not a hurricane. We looked at weather forecasting and we put station symbols on a weather map. And remember that up here is the temperature, over here is the air pressure. This shows the wind speed. The number of flags show the winds, or feathers rather, show the wind speed, and the direction is shown by the wind vane. The circle is filled in based on how much precipitation there is. And then there's a chart to show what kind of precipitation is going on. And remember that systems move from west to east in the United States, and in general, whatever's happening in Minnesota today, we're going to get tomorrow. Know what a cold front looks like on a weather map with the shark's teeth, and know what a warm front looks like with the half-rounded teeth. And that leads us to the end of it. So that's just a quick review. Go through the slideshows, go through your old quizzes. Good luck.